Hi everyone, welcome to the IGCSE Design and Technology Paper 3 Resistant Materials. Today I'm just going to use example of candidate responses and examiner comments. Okay, so the overview of this video, I'm going to revise example paper of a candidate, and we are going to just look at the questions, see what was answered, and look at the examiner comments feedback. So we're also going to look at common errors to avoid, and then also right at the end of the video of the example paper, I'm going to put up study checklists so that you can just go through it and see what do I need to study to get to answer any questions of a resistant paper. Hi everyone, so I'm going to go through the example response paper 3, and I'm going to discuss basically just what is expected, the study focus, and the answer style. So there will be 11 questions in this paper, and if you are looking for this paper, it is the June 2024 question paper 32. All right, so question 1. Figure 1.1 shows parts A and B of an incomplete drawing of a twin mortise and tenon joint. So the first thing that you look at the example that is given, and what I want you to look at is this is the part where there's no lines, there's nothing drawn there. This is where you are going to draw your tenon joint. So I've already made some notes on this paper, but to quickly draw your attention to part B, this is where you are going to show the twin joints. Oh, sorry, tenons. So as you can see, what I've noted here prior to this video, the measurement is accurate to where it's supposed to go in. And this, if you draw on this side, it's going to be marked wrong because that's not the side that's going to go in to the block. Okay, so B joins from this side into block A. So what are examiners looking for? Okay, so examiners are looking for accurately drawing twin tenons to match the mortarizers. So it needs to fit in properly. So your study focus would be here woodworking joints, projection, and drawing accuracy. Use your ruler, projection lines. Do not do freehand drawing or guesswork. Do precise and precision work for the full marks here. Okay, it's a 3-point mark. So if, first of all, is it on the correct side? Did you use straight lines? Is the measurement quite similar to block A, and would it fit in properly? All right, so please work on your drawing skills if that's not up to scratch. But most of all, you should have practiced it quite a lot beforehand. Okay, on to question 2. So, figure 2.1 shows a label from the front of a box of steel bolts, as you can see there. Okay, so what they are looking for is A, B, and C. This is M is the metric, so this is metric. The 10 refers to 10 millimeters, the diameters of the bolt thread. So 10 is diameter, and your 50 then, C is the 50 millimeter length of the bolt. Okay, so this is length. All right. What you should focus on here is your standard fastener terminology. This could be other materials as well. It might not be the specific fastener that they are going to ask you, but you need to know A, B, and C. Doesn't matter what tool or what, if it's a bolt or maybe a nails, anything that like that. It could be anything. You need to know this, what you see and what it indicates. So what they've noted is that a lot of the candidates were unfamiliar with the terminology, and like say for instance, they didn't know what these symbols are standing for. So go and look at a few different examples. So like say for instance, wood screws would be similar. So this should be fairly easy if you know your terminology and your fastener tools. Okay, so the answer style is very short and clear, metric, diameter, length. Okay, this is a little bit more lengthier, which is also fine because it explains it very nicely. But if you do quick short answers, that's also fine. Just be sure that your examiner will clearly understand what you understand. Okay, also 3 marks for this test question, and obviously 1, 2, 3. Okay, so go and study your different fastener terminology and look at symbols so that you can answer clearly. Okay, question 3. Okay, so question 3. Many products are manufactured with a built-in obsolescence. Explain by giving an example of a specific product what is meant by, sorry, I've lost my place. Explain by giving an example of a specific product. What is meant by the term built-in obsolescence? So, first of all, you need to know the terminology. If you are unsure, try and just recall what it reminds you of, but you should know this. So, first of all, what is expected here is a definition of the product example, and your study focus should be, in this case, like design for life cycle, consumerism, how long is the product going to last, is it something that is lifetime, does it have a warranty, is it expected to last long or not? So in this case, the word obsolescence means that the practice of design or making a product in such a way that it could be used for a certain time before the consumer needs to replace the product with a new one. So say for instance, this person gave an example. So obviously a mobile phone or an iPad which needs to be updated periodically, were good examples of products with a limited lifetime. So in this case, say for instance, you buy a phone, there's a warranty or a guarantee for 2 years. That means that, say for instance, after 2 years, maybe the battery is dying, it's not coping anymore, and you need to replace either the battery or the whole entire phone. Okay, so in the case of like an iPhone or an iPad, you'll have to replace the whole entire product. Okay, but I think their lifetime is a little bit longer, but you get different products with this Absolines in mind. Okay, then what I want you to focus on is the definition, number one. So here the person has explained the definition. That's for 1 mark. And number two, they have given a specific product or an example here. So that's 2 marks, and they would have gotten the 2 marks for it. And what the examiners have noted is that the candidates were unfamiliar with the terminology. So go through all your terminologies in your textbook so that you can revise, and if you do get a word like that, for instance, you'll know what to answer. All right, then for question 4. Okay, so for question 4, they're asking, it shows you 2 different types of calipers, A and B, measuring the diameters of a round bar. Okay, so first of all, they're asking you to label or name the type named B, and it is a vernier caliper. So know the difference between the different tools so that you can answer that correctly, and then explain why the measurement taken by A will be less accurate than measurement taken by B. So this is where you have to know your tools very well and compare them. So in this case, it's measurement tools, and it could be limitations as well. So what is your tool and the limitations that it gives you? So in your paper, for instance, it might be 2 other tools that you have to know the tool and the limitations. So question A, you have labeled it. Question B, you can give a proper answer of why B would be more accurate or suitable than A. So in this case, when caliper A measured the diameter of the round bar, it would be placed against the end of a steel ruler so that the measurement could be read off. It was possible for the measurement taken to be moved during the transfer from the round bar to the steel ruler. The diameter of the round bar taken with the caliper B could be read off directly from the caliper and therefore would be more accurate. So first of all, 2 very good reasons why A would be less Right. Sorry, I lost my train of thought there. When Okay, so first they explain when caliper A is measured, it might be moved, and this is the reason why it has limitations. And here they explain why B is more sufficient and why it would work better. So it's 2 marks for A, 2 marks for B for a very good explanation. Okay, so first of all, you're going to state the name of a tool. Then explain human error reading transfer versus direct reading. So I want you to focus on that the tool could measure correctly, but if you move it incorrectly, that could be an error. Okay, so what the examiners have said is that candidates focused on human error where reading the measurement taken from the steel ruler. So remember that it should also be stated that it could be the tool itself if it's not a human error. And then both clippers took measurement that involved human error. You could also read incorrectly. So don't just focus on the human error. Say that the tool could have moved. You could have not placed it correctly on the ruler, but at the end of the day, your reasoning should be very well written. Okay, so you will apply your knowledge of what you know about the tools. All right, so question 5. Question 5 asks you about composite materials, and prior to the recording, I have made a note for myself to remember to talk about this. So first of all, I'm going to talk about what composite materials and alloy materials. Just know the two differences between the two materials because you could either be asked about composite materials or alloy materials. Okay, so the question asked that CFRP and GRP are examples of composite materials. Complete the name of the composite materials. Straightforward, very easy, 1 mark each. You complete the word. Okay, so carbon and glass was what the 2 words that they were looking for. But what I want you to focus on is that when you study, is the different composite categories and materials. It could be other materials that they ask in your exam, so know your materials and study obviously the 2 differences as I mentioned. Okay, sorry, my light is making funny. I think that was the best. Okay, so yeah, not too much to say here, but just revise your materials so that you can name them or label them. All right. Question 6. So question 6, well, is about your different, basically like smart materials. So in this case, they have used a memory alloy, SMA, when it is heated. So they have drawn stages 1, 2, and 3. And the question is, show what happens to shape memory alloy when it is heated. So you are going to draw complete figure 6.1 by drawing the shape of the SMA at stage 3. So they obviously had to draw this one. And they wrote the shape would be the same as at stage 1. So that is the candidate's label. Okay, so make sure that you know different smart materials. So even though the question asked the candidates to draw the shape at stage 3, the candidates were awarded the mark for the shape if it would be the same at stage 1. So even though the question is to draw, still do make a little note so that it is easier for the examiner to see that you understand what is expected. It's the same as at stage 1. So what they also have said was there were many shapes drawn that were incorrect, and the candidates needs to be familiar with several smart materials. So don't just learn one, go and study a few smart materials so that you can answer any type of material. And think that a lot of the smart materials were made so that it could go back to its original shape. If you think of a memory foam from a bed, this could be exactly this. This is what it looks like beforehand. Somebody lies on it, we produce heat, and it like goes in. It's a little bit bent down, and once you stand up and you leave the bed, now it's going back to its original shape. And that's the important part, that it goes back to its original shape, same as stage 1. Okay. All right, so not too much to say there as well, just to study your smart materials. All right, so question 7 is asking you to show a copper dish being beaten into shape. When the copper is beaten, it becomes work hardened. So complete the sentence by adding the correct term for the list, from the list, sorry. So you are given soaked, alloyed, annealed, and tempered. So you have to then make a decision. So to make the copper softer and easier to work, it must be annealed. So you basically just have to know these terms. When it is, what purpose does each of these materials have for when you make things? Like say for instance glass, it would be tempered. Okay, so annealing is a basic process designed to make metal softer and more malleable so that you can shape it. So there are 4 processes specified in the syllabus that deal with the heat treatment of metal. So you guys need to be familiar with all 4 of the processes. So please study these 4 processes so that you can, should you get a different question, you can still be able to answer it. Then name the item of equipment labeled A. Going back to the picture. Okay, so you need to label that, and that is a sandbag. Okay, so candidates who named the item of equipment as a sand pad were awarded a benefit of doubt mark. So they might not always be that lenient towards your, like if it's not correct, it's not correct. So they might not all be lenient. So for instance, a lot of candidates said sandpad. So that might be the only reason why they were giving you the benefit of doubt. But make sure that you have the correct terminology. So focus, your study focus is heat treatment and the forming tools. So know what is the treatment and what tools are used. So this is one word answers. As you can see, 1 mark, 1 mark. Okay. Next, I'm going to go to question 8. Almost there. A few more questions left. And here we are going to look at a sketch. So it shows a hardwood box with a hinged lid. So obviously the lid opens a little bit too far, and sides it's giving you measurement, and the lid must open to 60 degrees maximum. So use sketches and notes to show a fitting that could be attached to the lid and box to prevent the lid from opening more than 60 degrees as shown in figure 8.1. Okay. First, they drew it closed, folds flat, and they have drawn the piece that they want to use. Then they have drawn it open up to a 60 degree. So important, if it says 60 degree, use your okay. So use your protractor and measure your 60 degrees and then draw your box opened at a 60 degree. You can more or less see here, it should look similar in shape. Okay, label again. Make sure that you label everything nicely. Screw, lid, brass tape can be fitted inside or outside the box. Rivet allows to stay to fold. Screw, box, 3 marks. Okay, so you are going to have a sketch and explain the fitting to the limit lid, and what you can focus on studying is stays, catches, and hinges. So whatever you get to answer, so for instance, I give you a different picture, perhaps you need to work on a gate, you're going to do hinges, and you just draw it very nicely. Yet again, use your rulers, use your protractor, use the tools that you have to make it clear, label it, and note how it attaches. So for instance, in this case, a screw. Okay, on to question 9. Okie dokie. So figure 9.1 shows a plastic bending cup and the symbol for the plastic from which the cup is made. Okay, so here's your cup, here's your plastic. Okay, and here you have to name the type of plastic, polystyrene. Okay, one word answer, 1 mark. So in this case, you're going to identify as maybe a different plastic that you have to name. And what I'm going to what you need to focus on is your thermoplastics and your recycling code. So this is your recycling code. So say for instance, there's this company in South Africa, they collect lids and they only take lids that's labeled 2 and 5, for instance. So know what it stands for just in case it's the different, it indicates the plastic, yes, but it also indicates for your recyclers to know exactly what type of plastic it is. Okay. All right, that should also help you with the different types of plastic as well. Okay, so it's very short answers. Then question B. Many fast food outlets are encouraging customers to reuse their drinking cups. Give two benefits of reusing your drinking cups. So this candidate said reusing plastic drinks cups uses less resources, such as oil from which the cups are made, and results in less waste and less litter. Okay, so the two very good answers. And if you think about it, that's always going to be the case. We always want to have sustainable, you should think about sustainability and reducing waste and saving oil. So depending on the type of plastic that they are asking for, just think about what is the benefit if we don't use that plastic a lot. Okay. So know your plastics. Question 10. So question 10 is going to be a sketch and note method of a swinging joint, and you have to name the materials as well. So let's quickly look at this specific question. Figure 10.1 shows part of an incomplete design for a towel rack. The backboard is made of hardwood and the arm is made from 8 radius aluminum rod. Okay. Then you're going to sketch notes to show how the arm could be attached to the backboard and allowed to swing as shown in figure 1. So obviously there the arrow shows you it needs to swing. Name the materials used. They are using an aluminium bracket screwed to the backboard. Okay, so screws and the bracket. So this could be anything from fixings, brackets, and then like your practical construction materials. So you need to be able to like answer any question in this particular that would involve your fixings and brackets. So go and study those so that you can answer any question in this regard. So obviously your picture should be it should be a functional sketch. So this is you can definitely see that this is a proper bracket, and they've named the material. So for instance, they could have said steel bracket, but they're more specific and it's an aluminium bracket. So what the examiners have also noted is that the candidates were awarded 1 mark for showing the metal bracket attached to the backboard in which the arm could sit, and 1 mark for construction showing the bracket screwed into the backboard, and 1 mark for naming the suitable material for the bracket. So let's just quickly, I'm going to just run through that. Okay, so that's 1 mark for the drawing, 1 mark for saying aluminium bracket, and 1 mark for showing how they have done that. Okay, so that would be a full 3 marks. So what they also have noted is that the alternative method showed a block of wood joined to the backboard with a hole drilled in the block to take the aluminium arm. So that was a second option if you didn't use this type of bracket. Now, the poor quality of some sketches meant that the methods of the attachment were unclear. So make sure that your picture is clear so that they can see exactly what you are drawing. And some of the methods that was mentioned was not going to work for this type of what they wanted. If it wasn't going to be allowing the arm to move, they wouldn't have been awarded that mark. So it's important that the candidates address all parts of the question. So some candidates also having sketches at a practical method did not name a suitable material, for instance. So then you won't be awarded all full marks. So say for instance, this student didn't say it's aluminium. They wouldn't have gotten like a mark for that, which is important. You want full marks. You don't want to miss out on any of your marks. Okay, so question 11. You are looking at a portable toolbox made of soft wood. Your very first question is going to be what name a suitable softwood for the toolbox. So you can name any suitable ones, like the examiners have given a few examples like pine, Paranja pine, Douglas fir, spruce, whitewood, and western red cedar. And just be careful not to name hardwoods. If you name a hardwood, you're not going to get the mark for it. So know your materials. Okay. So your properties of soft and hardwood is different. And the question continues. Sorry, no, just trying to focus. There we go. So figure 11.2 shows part of one of the hinged sides, which is made by gluing together two soft wood boards. Give one reason why two boards are glued together rather than making the side from one board only. Okay, so this reason was two boards glued together are more resistant to warping. So here they give you an alternative reason they could give was softwood trees do not produce wide enough boards. And then many answers such as the boards would be stronger or more durable were too vague. Okay, if you're going to say stronger, rather use the word more resistant, and like in this case. Okay, so yes, it does mean the same thing, but you are writing like a Cambridge paper. You're not just going to use simple English. You're going to say it's more resistant. That's exactly what the reason is. Okay. So that's one. Okay, B2. Use sketches and notes to show how the two boards could be glued and clamped together. Name the type of clamps used. So this is where you use a sketch and you are going to label it, and here scrap wood prevents damage to the boards, give more even pressure. Okay, so you can see here they've made like little lines to indicate that, and then 3 cramps spaced along the woods. Okay, so it's spaced nice and evenly, and then 2 cramps underneath and 1 cramp on the top. Okay. So just to pause there for a second. Okay, I can't remember. I've lost my train of thought. Sorry. If I remember, I'll go back. So, yes, on question B, just to focus on the examiner's notes, is that 1 mark for a minimum 2 cramps showed across boards, 1 mark for the use of scrap wood between cramps and boards, and 1 mark for the named cramps. Okay, so many candidates named G clamps, which would not be suitable for the clamp board. It's 325 millimeter wide. The use of scrap wood was missing from the majority of answers. Okay, so note to self that this is important. Okay, so your scrap wood. All right. Then the candidates were not familiar with the techniques required to join boards edge to edge. Okay, B3, state 2 checks that should be carried out after the board have been glued and clamped together. So number 1, the 2 boards were lying flat. Any surplus glue has been removed. So the candidates could also have checked that the board were clamped tightly but were not over tightened. Otherwise, it would break, whatever the case. Okay, C figure 11.3 shows 2 types of hinges that could be screwed to the toolbox to allow the sides to open and close. A and B, name them. So number A is butt hinge and T hinge. Know your different hinges. And the T hinge was more widely recognized, but more recognized than the butt hinge. Okay, so candidates need to be familiar with the different varieties. So you need to study your different types of hinges. Okay, so explain why hinge B would be more suitable than hinge A. Okay, so this candidate answered, one leaf of hinge B is much longer than that of hinge A and would cover a greater surface area of the wood to provide more strength and support. Okay, so nice, good answer. It's 2 marks. Always check what your question is out of so that you can see if it's a short answer or a longer answer. Okay, so what the examiner have said in this case, many candidates recognized that the suitability of the T-hinge was dependent upon the longer leaf, but were unable to explain that the longer leaf would cover a large surface area and therefore provide more strength and support. Okay, if you are writing, sometimes you do forget to apply your knowledge, but it's quite obviously when you look at it from this perspective. Just remember to, if you do get stuck, to think and apply what would the reasoning be behind it. Okay. Then D shows details of a set of screwdrivers that will be stored on the inside of one of the hinged sides of the toolbox. So use sketches and notes to show how the set of screwdrivers could be stored on the inside of a hinged side. The method of storage must hold 6 screwdrivers safely and securely when the toolbox is carried and allow for easy access. Okay. Again, give details of all materials and constructions used. That's always important. Okay, so also remember now, there's your measurements, picture, nice lines, clearly can see that it's well thought of, and labeled. Okay, so screw holes, back, dowel joint, shelf, and then the material is fine size of the back and the shelves. Okay, so I'm going to quickly just look at what the examiner said. The candidate is awarded the first 2 marks because their design shows a practical idea. 1 mark is awarded for 6 screwdrivers stored securely, allowing for easy access, and 1 mark for the method showing the screwdrivers attached to the inside of the hinge side, and the final mark is awarded because the material named is appropriate. So poor quality and accuracy of sketches meant that the design idea were difficult to understand. So remember, like I said, always your drawings should be nicely and to do it with rulers and make it clear so that you can get full marks for your drawings. And then going on to question E, use sketches and notes to show how the hinge side shown in figure 11.1 could be held securely and prevented from opening when the toolbox is carried. Okay, this is toggle catch, and again nicely labeled and drawn. So let's quickly look at what the candidates were awarded marks for. So 2 marks for giving a recognized practical type of catch, and 1 mark for adding details describing how it would be used, so your labels. And they've actually also made A, B, so this and this goes together, and that's your second part. So that's actually very nice of them, so that the examiner could clearly see what they were drawing. So some candidates showed a workshop made catch such as clasp, strap or clip that's swiveled across and was secured to the handle. Catches are pre-manufactured components with which candidates should be familiar with. So the candidates need to present their sketches clearly and accurately when answering this type of question. So for that one, I would say go and study your toggle catch, your hasp and staple, anything that could secure boxes or things when it's closed. There's many different ones, so you should know a few of them. Okay, moving on to question F. So the handle enables the toolbox to be carried. Figure 11.5 shows a method of joining the handle to the ends of the toolbox. Name the joint that is shown in figure 11.5. It's a dovetail. Okay, so what you need to study is the different joints. So it could give you any other ones, and you should know what it is and be able to label it. So it's then going to ask you why the method shown in figure 11.5 was considerable strength when joining the handle to the ends of the toolbox. So again, if it's going to be a different one, you need to be able to answer it to explain why. So in this case, the dovetail shape prevented the handle from being pulled out when the toolbox is lifted. The dovetail joint is wider at the bottom than the top, making it secure when carrying the toolbox. The tapered shape means that it cannot come apart when pulled upwards. Okay, so again, well answered, your 2 marks, and explaining exactly why the shape would be best for the specific toolbox. Okay, so many candidates stated that if it was because of more surface area, which was not correct. Okay, in this case, obviously when you're going to lift something, it's going to go up, and this is going to make it more secure that it doesn't go out. Okay, so obviously every joint has its purpose. So just go and study your different types of joints and why, what's its specific reason and shape for. Okay, question G. So figure 11.6 shows a commercial manufactured toolbox made from plastic. So give 3 advantages of using a toolbox made from plastic rather than the toolbox made from soft wood shown in figure 11.1. So this would now be just comparing the two, and in this case, this is a molded shape with no sharp corners, lighter weight than softwood toolbox, more durable than softwood toolbox. Easy 3 marks depending on what you have to compare it to, but usually if you know your materials well, you would be able to answer this with ease. But many candidates did not read the question carefully and missed the important phrase, advantages of using a toolbox made from plastic. So they then said why the softwood toolbox would be better. So please remember that you should just read carefully always, doesn't matter what question it is. Okay, so in this case, they wanted to know why the plastic is better. Okay, so just read carefully, and then many answers related to this spread of production of the plastic toolbox. For example, the toolbox could be made quicker using the injection molding process. Okay, so if you have to manufacture a lot, it's going to be cheaper and more quicker to your shops, for instance. So you can also think of your production, how it's produced. And then, for instance, this is not, if you're going to do a wooden toolbox, it's going to take time and it could be more like something personal. Okay, handmade products are usually a little bit more expensive anyway, so maybe the toolbox would be cheaper anyway if it's plastic. Okay, all right, so yes, question 11 is a very long question. It's almost like it's its own section on its own. So what I'm going to do is I'm going to put this into a PowerPoint, and I'm going to give you a little bit of tips, almost like a little checklist for your topics so that you can see. So the topics that I'm going to put in, I'm going to just write it here at the back. So the checklist that I will do is for your joint and fixing. I'm going to do fasteners, so your bolts, your screws. Then the other things that you need to study, like your materials. So that would include wood, metal, plastics, and you also would have to know your composites, and your smart materials. Okay, so that would be like your alloy. Okay, so and obviously also the applications to it. So I'm going to make a checklist, like a quick study checklist, which I'm going to put in a PowerPoint, which you can just like when you study these topics, you can make a quick checklist for yourself to see have you studied it all. Just a few more that I almost forgot about is your tools and equipment, as well as your processes. Okay, your processes is quite important, especially if you're answering that last question. You can add that to a pro or con, and then perhaps your designing concepts. Okay, so what I'm also going to add for a quick checklist is your answering skills. Okay, so that is short definition, sketches, bullet points, and then longer answer questions. So know what your command verbs is. And like I said now with question 11, read your questions very carefully. Don't make mistakes. Okay, if you have to, read it twice. All right, everyone, thank you so much. I will um, add this to a PowerPoint so that it's written, you can copy it, and then just check that you have covered everything for your studies. Bye-bye. Right, so next up is the study checklist. It's going to have 7 parts, so you're welcome to join, to pause every time it goes to the next one, copy it into your study notebook or study schedule to make sure that you cover all the study material. And that's it. Thank you so much. I hope you enjoyed it and learned something. Goodbye.